All right, so here is our Unit 9 test review for Algebra 1. So I just wanted to kind of walk y'all through the study guide, but I first want to say I would first just really highly recommend you guys work through this on your own first and then check it with me, because that'll be best practice for you to be able to figure out, okay, do I know this? Do I not? And so good way to test your understanding. Okay, so let's look at this first equation. Looking at this, we always want to look at the x. If the x is not squared and it's not in the powers place, we know that it's a linear function. Okay. Then let's move on to this one. So this one, the x is not squared and it's not in the powers place, but do we have more than one x? Yeah. Oh, you can't see. Let me start over. So this one right here, right, we don't have, it's not in the powers place, it's not in the powers place, and it's not squared. So we'd immediately think, okay, is this linear? But if we multiplied this out, so if we use our little box method, had x minus 2, x plus 6, x times x is x squared. So look, we have that squared is what we're looking for to figure out whether it's quadratic or exponential or linear. So we know it's quadratic because this x is squared. Okay, let's move on to the next one. Over here is the following equation: linear, quadratic, or exponential. Again, we're going to look at the x. If the x is in the powers place, guess what? It's exponential. Okay, so those first three are pretty straightforward and very similar to the quiz that we had. Sorry, I don't know how to get rid of this shadow. Hopefully you can still read it. So is the following graph linear, quadratic, or exponential? So let's look at this. See if I can zoom out. Yeah, look at that. Okay. So if we have a graph and it's really, really slow, like it's not really going up much, and then it suddenly just takes a strong incline, we know that that is an exponential equation. All right, this next one is a line. So we can determine that this graph right here would be a linear graph. Okay, pretty straightforward. All right, this next one, we have a U-shaped curve. That U-shaped curve has to do with a quadratic. So my answer here is quadratic. Over here, we have something that goes up, kind of curves a little bit, and then goes up again. So is this a U-shape? No, it's not a steady incline up, and it's not a line, so it's actually none of these. It's not exponential, linear, or quadratic, so we're going to say none of the above. Alright, so now we're going to go to the table, and if I'm going too fast, just pause the video, rewind, and see kind of what can help you, or what problems you're struggling with, or things you need to go back over. So I'm just going to try to go as quick as I can. So this video isn't super duper long. Okay, so is the following linear, quadratic, or exponential? Let's look at this. From -1 to 1, we always want to check first for linear. Okay, is it adding by the same amount, or is it a constant rate up? Are we subtracting the same amount or adding by the same amount? So let's see. From -1 to 1, we're adding 2. From 1 to 3, okay, we're adding 2. From 3 to 5, we're adding 2. And then from 5 to 7, we're adding 2. Look at that. Okay, so we're checked for linear first. Guess what? It meets our linear criteria, so we're going to say yes. This table is linear. Okay, let's go down to this one. Here we always want to check for linear first. Okay, so from 7 to 4, we're subtracting 3. And then from 4 to 3, we are subtracting 1. Oh, look, we're adding 1, and then we are subtracting 3 again. Or, sorry, not subtracting, adding 3. So that does not meet our linear criteria, okay? So let's then look, okay, are we multiplying the same amount? 7 times what gives me 4? And if you're not sure, let's just do 4 divided by 7, okay? We'll do 4 divided by 7. Okay, we have a common ratio of like 5.71, okay? Then let's go down to 3 divided by 4. Okay, we're just trying to see, okay, are we multiplying by the same amount? So 3 divided by 4, oh no, so 0.75. So this will not work. So we've ruled out exponential. So those are the two we can roll out immediately. And then usually whatever's left over, we're going to pick quadratic. But my quadratic definition is the second difference. We took the first difference. And if our second difference is the same, so if we do this thing again where we go, okay, what happened from -3 to 1? Okay, we added 2. From -1 to 1, we added 2. From 1 to 3, we added 2. If that second difference is the same, guess what? It's quadratic. Okay? Another cool thing to look at when we're looking at these tables is if it starts up, goes down, and then starts going back up again, right? It kind of models that U-shaped curve that we were talking about, right? Where we start up, go down, and come back up again. So if you notice even just the numbers looking like that, then it's probably quadratic. But I would still be on the safe side and try that first. All right, for this next one, you could probably guess what this one's going to be, but we'll see. All right, so we want to first check for linear, okay? Linear, we're adding 3. We're adding like 12. Okay, so it's definitely not linear. All right, you can already tell that. Then let's go ahead and go to exponential, okay? Let's do 4 divided by 1. 4 divided by 1 is 4, okay? Let's go move down. 16 divided by 4 is 4. Oh, look at that. 64 divided by 4, not 4, 16, right, is 4. And then you could probably guess the last one. 256 divided by 64 is also 4. So we are getting the same thing when we are multiplying that. So multiplying that out, so that's exponential. All right, so this is a question y'all saw on your last quiz. The average rate of change, we're going to move on to average rate of change now. Average rate of change is of a function, the average rate of change of a function is constant for which type of function? So it's constant for a linear function, okay? Constant meaning like you're adding the same amount or subtracting the same amount each time. All right, so then it's asking me, okay, what is the average rate of change of f of x, so this is f of x, over the interval 2, 4. So let's find, so this is where we need to find x is equal to 2. So x is equal to 2, we know about, right here, because this is up to 5, so we counted 1, 2, 3, 4, 5. Okay, 2 would be about here. So let's draw a line straight down till we hit our graph. Okay, so we hit our graph at about, see, this is -5, -6, -7. So 2, -7 is the first point that I'm going to use. Okay, then I'm going to go over here to 4. Okay, 4 has got to be right before 5, so I'm going to keep bringing it down. And notice there's going to be dots on the test as well, so if you see these dots, they should help you. Okay, and then it's just 1 past 10, so that's -11. So at x is equal to 4, my y value is -11. Okay, so now that we have our points, we're going to use our slope formula. y2 minus y1 all over x sub 2 minus x sub 1. Okay, so I can label these if you want to. Okay, and I'm going to subtract my y values, so -11 minus a -7. So make sure you're still including the negative and negative and then changing that to a positive as soon as you can so you won't mess that up. And then we'll do 4 minus 2. So 11, -11 plus 7 is 4, or -4, sorry, all over 2, so this is -2. So my average rate of change, oops, got cut off here. My average rate of change for this graph from 2 to 4 is -2. Okay, so then it's going to be asking me, okay, what is the average rate of change of f of x over the interval 2 to 3? So again, when x is equal to 2, again, this is 5, so this would be 1, 2, 3, 4, 5. So 2 is here. So I'm going to go all the way up where my graph where that point hits my graph, and then I'm going to draw a line over. This is 1 right before 5. So it's gotta be 4. So 2, 4 is my first point. Okay, then I'm gonna look where x is equal to 3. 3 is just 1 before, so I'm gonna keep going up, and there should be a dot at these points, okay? Okay, and you can either look, it's 2 after 10 or 5, 6, 7, 8. So 8, so 3, 8. So these are my 2 points. Again, x sub 1, y sub 1, x sub 2, y sub 2. I'm going to plug it in my slope formula. You need to have this formula memorized. I'm not going to give it to you. Okay, we've been doing this enough. You should be able to know what that is. So this is 8 minus 4, and then 3 minus 2. 4 all over 1, or 4 is my average rate of change from 2 to 3 on this graph. All right, so then we're gonna look at an equation. So this one involves a little more work. So we're gonna start with x is equal to 0. So when x is equal to 0, I'm gonna plug it in. 5 times 0 is 0, minus 3 is 3. So my point here is 0, 3. Then I'm gonna do the same thing over here, but with 5, because that's what it's given to me. So I'm gonna do 5 times 5 minus 3. 25 minus 3 is 22. So 5, 22. Those are the points I have, and then I'm going to use the exact same thing I did for the last problem. X sub 1, y sub 1, x sub 2, y sub 2. It doesn't matter where you put these. Okay, I can switch these up when I'm labeling them. Like I call this one x sub 2, y sub 2, and this x sub 1, y sub 1. It doesn't matter. You're still going to get the same answer. Okay, so I'm going to plug these into my formula. 22 minus 3. Let's slide this over some. Minus my other y value, which is 3, and then 5 minus 0. So 22 minus 3 gives me 19. And then divided by 5. So I'm just going to put that on my calculator. 19 divided by 5 is 3.8. All right, so that's my average rate of change from 0 to 5. All right, so let's go ahead and move on to this next one. Same thing. Okay, I'm just going to plug it in for x is equal to, this time, -1. So I'll plug it in, -2 times -1 squared. Okay, that, let's first do exponents. Don't multiply and then square. We always do the exponents first, then multiply. So -1 squared is a +1. +1 times -2 will give me -2. Okay, so -1, -2. Be really careful with your signs for these problems. Okay, I see a lot of people mess it up there. All right, then we're gonna do for x is equal to 2. So -2 times 2 squared equals 2 squared, which is 4. 4 times -2 is -8. So 2, -8. So be really careful when you're plugging these in. Make sure you're doing squared first, then multiplying by what's in front. Okay. Then, let's see, I'm going to go ahead and work out the problem over here. We're going to take our difference of our y's, which is -8 minus -2. And again, if we have two negatives, that becomes a positive. Divided by 2 minus -1, which again, this will become a positive. So this is -6 all over 3, or -2. So -2 is my average rate of change from -1 to 2 over that interval. All right, let's keep going. All right, so for 16, now we're gonna deal with tables. I feel like tables are probably the easiest because it's just given to you here. So at x is equal to 1, which is what we're looking at over here, my y value is 4. And then for x is equal to 3, my y value is -20. Okay, so I'm just gonna plug it, take the difference of my y, so -20 minus 4. And then 3 minus 1, this is -24 all over 2. And so that'll give me -12. So my average rate of change there is -12. All right, same thing. All right, my first point is 0, 9. Looking over here because it's asking for the interval from 0 to 2, so I'm going to use the x value at 0. And then 2, right, is my other x value, and I'm going to find that y value, which is 5. Then I'll plug it in my formula. 5 minus 9 all over 2 minus 0. And if it still helps for you to label them and then use your slope formula, that's fine too. I'm just kind of skipping that step. So 5 minus 9 is negative 4. Divided by 2, that's negative 2. There you go. Oh, that's a pen mark. That's not a hair. Okay? All right. 3 more problems. All right, so again, more tables. Again, we're just looking at those x values. My x value at 1, my x value at 1, my y value would be negative 4. And then my other x value that I'm given is 3, so my y value at 3 is negative 64. So I'm going to do negative 64 minus negative 4, so that becomes plus, divided by 3 minus 1. Okay, so that's negative 60 all over 2, which is negative 30. So that's a big average rate of change. So that means this graph like goes down super, super fast. Okay, from and over that interval. Okay, so my same thing at 0, my y value is 6. And then at 3, my y value is negative 21. Okay, and I'm just going to plug it in, negative 21 minus 6 all over 3 minus 0. Negative 27 all over 3 is equal to negative 9. So my average rate of change for that is negative 9. Okay, last problem. I hope y'all do not get this one wrong because I've given you this question a couple of times, or I think you got it for your quiz. In general, as x is going to infinity, which function eventually grows at the fastest rate? And that's going to always be your exponential. Okay, between these 3, all right, these 3, exponential is the one you're looking at. And I'm going to take out none of the above because there are there could be other functions that grow faster. So, and we're mostly just focusing on these 3. So don't worry about that. So I'm going to take that answer choice off, but I'm giving you a free answer right here. Okay, exponential is the answer to this question. All right, so that is it. Good luck on your test. Do the best you possibly can. If I went too fast, please go back and look at it. All right, love you guys. Bye.